that's got a mirror surface on the front of it, and
Right.
I'm recessing it into the wall. So that means I've cut the hole out with the sheeting over the top, but now I've got to cut a section out of the wall studs that
Oh, right.
are there.
You got
That's
to
going to
cut
be
out much.
a pain in the ass.
Do you have to cut out much?
What's that?
Do you have to cut out much of the wall stud?
No, there's only two studs, thankfully, that go through it. I've got to cut out about 6 centimeters
Right.
of it. Yeah.
Do you have to reframe, or you think it's still good enough?
No. I don't know. I won't have to reframe. It's not that critical.
All right.
So,
Okay. Hey, Blue. How you going?
Hey, good morning.
It's nearly 9 o'clock at
up?
night. Come
Well, not for me.
on. No, it's not. It's quite true.
Yeah.
I don't care.
It's just about to become afternoon here as well.
I don't care about you guys. I only care about me.
Fair enough. Fair enough. Ah, dear. There, I was talking about you last night. I think we were talking. Oh yeah, the guy and something or other was touting about people who don't do experiments. And people pointing out yes, they don't do the. No one's ever done the Cavendish experiment, so obviously your name had come up.
I would suggest that I actually have done that.
I think you've proved that you've done that. I don't think it's not like you sort of did a little version of it either.
And I'm pretty sure Cavendish didn't build his own apparatus either.
And I'm pretty sure he didn't fucking will do it with turkey thighs either. Biodual seems to think still that his Cavendish experiment was a valid scientific experiment. Oh, man. I haven't had the heart to bluntly tell him that it was a waste of time, but
Well, Biodual actually, he put us all in a bit of an awkward position. He really didn't want to have to defend that thing he did, but then in another sense, you almost had to.
Yeah. Well, you do occasionally have to point it, tweak it. Let's say it's more not defending, but just tweaking. Make it worthwhile. Ooh, what's my poll? I've seen if we're going to have a Lindsay marathon, but I'll see a 50% no, 50% tropical gap. So that's about the right. No one said yes, which is good.
That's based off 2 votes, isn't it?
8 votes.
Oh,
8 votes. So
okay. When I voted, it was just 2 votes.
yeah, it's been a 50-50. I expected more tropical gap myself, but that was.
Yeah.
Hey, Paul, is Mabbott still gone off the rails on pounds mass?
yeah. I asked him a question. I said, so Brian, answer me this question then. Is 10 litres of petrol always the same amount of fuel? And he hasn't answered me there.
He never answers. Where were you? I saw you asking questions in here.
Because 10 litres of fuel, it could be more or less depending on what temperature that 10 litres of fuel is, right?
Absolutely.
Yeah.
Which is why they have very strict standards about when they're measuring the reliability of those fuel pumps at the service stations.
That's right.
Yeah,
They've got corrections they apply.
they do. Yeah.
What is the
Well, when I was trying to verify the mass of the large lead balls for Cavendish, I had to be careful about that because the water I was using was at about 70 degrees Fahrenheit.
Yeah,
And that changes the damn density of it.
it does. So, did you learn the new meaning of the word asymptotic?
That was, well, pitiful.
It was, wasn't it? MC Toon says asymptotic. Brian says asymptotic.
Asymptotic,
And,
yeah.
and the hammer from the from the server says azimuth. I mean, how the hell do you get azimuth
Out
from
of that.
asymptotic?
I've got
Oh my god!
that debate because I haven't seen it yet, so I thought we could play a bit of that.
Just
It's Mr. Leaky. So I won't play the whole thing. I thought I'd play a little bit of it because I haven't seen it yet, but I did see some. It had been promoted quite a bit on different servers.
Well, when Toon asked him what the derivative of x squared was, and Brian came back with 2x, I said, "Holy shit! How did he do that?"
and then he said 1 over x or 1 over x squared. Oh dear.
Oh. Then I typed it in Google. What's the derivative of x squared? And it gives it to you immediately.
Yeah, so that's where it came from. Yeah.
Yeah, the follow-up question should have been, what is a derivative anyway, Brian?
Yes, not what does Google say.
Yeah, it was in that same question, Blue, when he was trying to give his answer. Brian made the comment, when 0 approaches 2.
He did. Did he say that?
He said that. Yeah.
Oh my God!
I'm thinking, I don't know how long I'm going to have to wait until 0 approaches 2. You know. Oh dear. Yes, he did say that.
Oh Jesus! I guess I was so flabbergasted by the idea that Brian actually figured out 2x. I didn't know what to think.
Oh yeah, well, he, went back to true form. He, what do you say? Trend goes back towards the mean.
It's a thing. I was going to put some of that on. So, do you want to listen to a bit of that?
It's a slope of a curve at a point, right?
Let's go.
Yeah.
Your 2-minute intro. Go ahead.
Hey, thank you for setting this up, Jaron. We'll see how this goes. I think it's an interesting idea, and I'm glad to be able to be on the first run of it. So
yeah, let's try it. It could be an evolving thing. We'll see how it goes. But I think I like it structured. I like it. And I think people will learn a lot from each debate. In 90 minutes, you're going to get, like I said, 12 topics, 3 questions each. You'll at least walk away with understanding what both these guys' opinions are and positions. So let's see here, Brian, you're up first, and you get to ask Toon your first question.
Yeah, Michael. So my first question is here just north of where they launched, in Jacksonville, Florida. They some people, me, I've actually tricked some people and pointed, since I learned perspective, I pointed to the horizon, when on a clear day when you could see an airplane fairly close to the horizon, and said, "Look at this space shuttle. Let's check it out." And they was like, "No kidding, man. It literally looks like a space shuttle on a clear day where you can see that far, going straight up for a couple minutes." I'd like to ask, how do you explain that in your model? Why does the airplane look like a space shuttle in the distance going straight up in the air? And then when it gets overhead, it gets straight. And then as it sets on the other horizon, it looks like something going directly straight down. How do you explain our local, sphere of vision, for lack of a better word?
Well, it's not a sphere of vision, but how do I explain that? That is simple perspective. Every single part of the path that plane is taking can be explained easily with just solving triangles. And if you don't need to know anymore the actual process of doing it. There are online calculators for it. So when an airplane is, say, I don't know how far away you can actually see an airplane. Let's say it's 20 miles, right? So when an airplane is 20 miles away from you and it's 6 miles up, right? Then you can solve a triangle, and you're going to say that is a very low angle, very small angle to the ground. When it's closer, say it's 10 miles away, that angle is going to be higher. When it's directly above you, well, of course, it's going to be straight up. And then as it passes over you, it's going to reverse that same line of that it did on the way there. And so that angle is going to progressively get smaller. So it is a simple application of a perspective, solving triangles. It's taught in middle school. In high school, typically you're taught to do it with actual sine, cosine, tangent. So,
right, real quick. I know we're going to jump topics, but real quick, it definitely. My whole point in saying that, maybe I should have specified, was that it doesn't appear linear, and you don't see it. 20, maybe 25.
It's not linear.
And
it's not linear.
You know why it's not linear? That's why it doesn't appear linear, Brian. It's not. Jesus.
It's an asymptotic relationship.
Right. So it's a squared relationship, or whatever you want to call it, but it's pretty much, you said perspective can.
No, it's not squared.
If perspective could describe it, then we'd see it coming up over the horizon at 1 degree. That's not the case. We see it at about 18 to maybe 25, depending on how clear of a day it is. And for the first couple of minutes, it literally appears like it's going straight up. So it's definitely nothing about it's linear, or logarithm, or anything you want to call it.
Arctangent.
I'll give some examples.
Hold on. Let me be clear.
My question is he talking about looking at the plane from the side, or is the plane flying towards him?
Forward or away from you.
Yeah, that was my thinking.
Go ahead.
We've gone off track already here, Darren, but
yes.
It's okay. I don't care. But I gave you the answer. It's not squared. It's not logarithmic. It's asymptotic. That's the word you're looking for. Use that word.
Okay, you're going with your question.
All right. My question. What is the bottom-up obstruction prediction formula for flat Earth?
Non-existent? No, I'm just kidding. I'm going to say, well, there's a couple of ways really to do this, man. The first way we do is get the distance to the horizon. So I think what Toon's looking for, and I'm going to try and keep this as honest as possible, is that 8 inches per mile squared is the measurement of the Earth, but has nothing to do with the hidden obstruction. So I'm going to try and keep it real. And what he's looking for is the formula. So, you have to start with the distance to the horizon, which is one way to do it is 1.22 times the square root of the observer's height in feet. And then you take that, and then you apply, let me see, I wrote it down. So X would equal A squared minus 2AD, where A is the obstructed height, and D is the distance to the object, plus D squared plus R squared minus R. So basically, but you can also do it, I've seen a couple things where you could do R plus H, where R is the radius. And I actually tried this, and it does actually work. It didn't look like it worked, but R plus H, which is the radius plus the viewer height squared minus the radius of Earth squared in feet, and all that square rooted. It actually does work if you do these numbers. But the real way that most people would do it too was I would say it'd be G over O to the OGL times E. That's the way most people do it, where G equals Google, and then the O equals Earth curve calculator, and then the LE, of course, is to type in your height and your distance, man. So that's how most people do it. I'm just joking, man.
Okay, your question, Brian. Go ahead.
All right. So number 2.
That was nice, that wasn't it?
Number 2 is.
Darren, write this down for next time. You need to give one quick answer back.
That was just gobbledygook.
We can do that.
Yeah,
we'll do that. Do you want to give your answer?
Yeah.
We'll do it next time.
Yeah, absolutely.
I just say all that was based on the globe. Okay, go ahead, Brian.
No, go ahead and respond to that. Was that what you were looking for, though? Like the 8 inches per mile squared?
I was looking for the flat Earth formula, not for the globe formula. You gave me the globe formula.
Oh shit! If you want a flat Earth formula,
yes, that was the question. It included 4 flat Earth in the question.
For flat Earth,
Brian, you goofball! You goofball!
Bro, it didn't say nothing about flat Earth, because I've already gave you my formula. It's 90 minus A over 90 times D times point A times 100 of A minus 1/2 A, where D is the triangulated distance to the sun or star, whatever you're measuring.
This is the bottom-up obstruction. When something
Right,
is
I gotta-
when something is
I've
40
gotta
miles
get
away,
the
how much will be
distance
obstructed? Oh my gosh.
Ask your question, Brian.
Okay,
Go to the next
I'll tell you
one.
what. I'll tell you what. I put in a 30-second video to explain this, bro. I thought we were gonna be honest. You're a veteran. I consider you a veteran. But if I got to re-show you this, I got a 30-second video for anybody who doesn't understand how the sun sets on the flat Earth.
I didn't ask how the sun sets, Brian.
No, we're not. We're going to go to the next. You ask your question now. We'll pass that one. Brian,
Well, he
you're up.
interrupted me during my formula, so I'm just saying. He's What exactly are you asking for, man? You don't want my formula.
He was looking for the bottom-up obstruction equation for a flat Earth, but let's move on to the next one. This is what I didn't want to do, is get stuck on something. He didn't. That's fine. We didn't get an answer for that.
What does he think? Wait. What does he think I was giving him? Just like
You gave me the globe formula.
No, I didn't give you the globe formula. 90 minus A over 90 times D times point A times 1/2 A is not the globe formula, bud.
What's that formula do?
I'm sorry. That's a refraction formula. Like I said, every flat earther might not agree with this, but this is just a pretty much a distance formula. And then from there, you figure the obstruction.
Okay,
by doing
we can do this in the topics if you
times
want, but move on to your next
Yeah,
question. Brian. Please. thank you.
Okay. Yeah, I'm not trying to not answer questions, just so y'all know.
Gotcha.
So, hold on a second, man. 1 second.
Yep. What are we on? His second one?
It's yes.
Did I say 90 minutes? I meant 190 minutes.
You gotta love Brian. He's always Brian. He's always the same. You gotta love him.
We'll get to the question here eventually.
Like, oh, just a second. Then he walks away.
Yeah, I don't, man. I'm sorry, man.
It's okay. We're ready.
It's so good.
Okay, number 2, man.
Yes.
Number 2 is, let's say, how would you, with an auto level, pushing it to its limit, pushing it to about, let's say, 100, 150 yards per shot, how would you lay out a straight line?
All right. Let me read what I was sent, just because I answered what was sent to me. If levels curve using an auto level and pushing the distance limits of 100 yards per shot, how would you lay out a straight line on land 1 mile long, your choice of elevation? My answer is I would hire a professional surveyor that has experience doing it and knows how and knows the process, and ask them to plot out a 1 mile level line at constant elevation. Then either myself or, if the budget allows, ask them to also do a calculated elevation above that, based on the globe known radius and how much it should be above that to be tangent to that point. So, for example, at 1/4 of a mile, which is 4.5 football fields, the second point would be 1/2 of an inch above that measured level. At 1/2 of a mile, it'd be all of 2 inches, and at a full mile out, it would be 8 inches above the level line. Now, the difficulty is how would you from a whole mile away see that 8 inches elevation change and just eye it and know how it's useful? I don't know how that could be useful, but at least it's a little better version than Brian Mullen's goofy thing where he thinks that he can build a perfectly rigid structure.
So to get this straight, you would lay out your straight line, and you said you would raise above your horizontal 2 inches.
No, you got in the first sentence you got it wrong. I would hire somebody that has experience doing it to lay out a level line, not a straight line. Level is a curve on the surface of the globe.
No. That's why I asked specifically for a straight line, because they're going to give you the same thing.
And I gave you the answer.
Same thing.
Well, I'll give you the answer again. Step 1: hire a professional surveyor to
We
lay
don't
out,
need
to lay out a level line.
Go back. He can go back and watch it again if he didn't hear it the first time.
All right, got it.
So go ahead. Your question number 2.
All right. How far away does the sun need to be to set over flat Earth?
Okay, now you said flat Earth. Okay, there's nothing about flat Earth. You're sitting there mucking with me and shit, and there says nothing about flat Earth in your first question. Nothing at all about flat Earth. It says what's the Earth curve? What's the formula for hidden height? There's no hidden height on a flat Earth as far as obstruction goes, you know. But anyway, I was trying to give you a formula, and anyway, so I'm going to refer to the way you answered. Is just is there is no obstruction.
So you're saying the sun never sets?
The sun sets. You're going to use Jaron. I don't even want to just play my Effie sunset video.
Okay. We're going to play this, and we start the clock going. Effie sunsets. All right, here comes.
Yeah. So in case anybody hadn't seen this, I figured he's a veteran. And this is a white light and a green light about over 100 feet. And the door just closed to a warehouse. And letting cold air in, and the white light disappears right in front of the camera. And then the green light disappears. Now, here's the way they describe refraction. And it ain't quite, I'm not seeing shit raising up. This is the sugar tank experiment. But for anybody who hadn't seen it, with just atmospheric lensing or magnification, you have the sun dropping and setting and not changing size. So I thought we were going to keep this honest. But you see the sun setting right in front of the camera, not change size on a flat Earth. There's two ways that can happen, dude. With just cold air, with just a little magnification in the atmosphere. I see where this thing's going already, man. So I'm going to act accordingly, man.
Yeah, I have a question. So then you're saying that the sun is literally on the ground? Because in this demonstration, the sun, your analog sun is literally on the ground here. So you're saying that the sun is literally touching the ground in reality?
Nope. Oh. Did the sun touch the ground? Did the sun touch the ground in either example?
Yeah, and your analog is right on the ground there. So okay.
No, I'm saying did it actually touch the ground though? In either example.
It sure looked like it was. Yeah.
Did it reach zero when it was just sitting above the ground in front of the camera?
I mean, it looked like your analog setup that you had there had the sun right on the ground.
Did it ever hit zero?
Did whatever?
Let's be honest, man.
Did either
example approach zero?
Did what approach zero?
The sun examples, the white light in the first video, or the picture of the sun, or the flashlight in the second video. Did either of them touch the ground or zero? The horizon is zero.
Yeah, it sure looked like you had placed the light, or whoever had done it. It placed the light right on the ground.
It looked like it.
Yeah.
But it didn't, though, right?
Yeah.
It didn't, though. But it did disappear, though, right?
Yeah. So what I'm getting is that you think that the sun is literally basically right on the ground for flat Earth. That's what I'm getting.
No, what I'm getting is that the sun right in front of your direct line of sight disappeared. There's two examples of how it could work on a flat Earth, plain as day, without the size changing on top of that.
Yeah. So step one, put the sun on the ground. Step two, it disappears.
Above zero.
Okay, we got it. Good. Above zero. What's the who's up? Brian, I think you're asking your third.
No, I think it's his okay, if it's my third question, yeah, okay. My third question is okay, so how in your model, and I know you have an explanation, man. Let's settle back down, too, man. I'm trying to get all shitty, man. I really ain't. I'm sorry I misinterpreted the first question. It threw me off a little bit, man. But let's keep this real, dude. I mean, you should have been very. So next question is, so how would you explain in your model? What would it take for the crosshairs to block half a mountain and appear below the water horizon, as exampled by myself and by George Notchek's Ice Lake measurement, and by Jessica Kozlowski and Tim Osmond's Great Salt Lake Strong's Knob measurements at like 7 foot above the Great Salt Lake. So it's not that rare. But how does the globe model explain that?
So to be clear, you're saying that I'm not familiar with your particular example for you, and I didn't look up Jesse and Tim's. I have seen George Natchik's thing. So you're saying, what you're asking is, how is it that if you're several feet above the water, that the crosshairs can be below the horizon, right?
Right. So we don't see in perspective the way you was trying to pass it off earlier, right?
No, yeah. So the way, and I mean, this is a great example. So when light goes through a gradient, a pressure or temperature gradient, it curves, and that curve has a radius. If that radius is larger than the radius of the Earth, then it will make something appear slightly higher. If that radius is smaller than the radius of the Earth, then it can cause distant objects to appear higher, significantly higher. So for example, the horizon can appear higher. And I personally measured in March of this year, I went with this NIST certified thermometer to a lake near me, and I measured the vertical temperature gradient. And at 1 to 1.5 meters, it was a full degree Celsius temperature change. For the radius of the curve of the light to be the same as the radius of the Earth, you need 1 degree in 10 meters. And this was significantly less than 10 meters. So that's causing the arc of the light ray to bend significantly more. So that's how you can see things above the crosshairs, is because refraction can raise things that much in certain conditions. And so, for example, George Natchik's lake example is a great one, because like I did, we know that at the bottom portion near the surface of the lake, that temperature gradient is pretty steep.
Okay, McToon, your third.
All right, my third one. What is the derivative of x squared with respect to x?
I mean, I'll give a couple different answers because I didn't seem like enough information, but the basic answer would be 2x or 1 over x squared.
Two
Or
X.
if you want to, if you want to take it a little bit further, though, if we're talking about derivatives, just for anybody who doesn't know, I'll make it as quick, Darren. Is where you're talking about the change. Basically, when we talk about it, we're talking about the change in the slope, like to a tangent or something like that. So if you want to say, if you want to give it a value, like if it ain't squared, that means it's a constant, which means it's a straight line. So we could just use rise over run, right? But if it's if you want to give it a limit, that's why I was kind of expecting something harder, like a limit. Like if you gave me 2, I'd say as 0 approaches 2, then I could have done something with it. It's so simple. I thought he was trying to trick me, but I don't know.
It's not a trick question.
Right. I don't know a ton about calculus.
It's really just 2x.
Right. 2x.
That's all you had to say.
All right.
Okay, so we are good. Everybody asked all 3 questions, yeah?
Yes.
Okay, so Brian, you get to name the first topic. Go ahead and make a little, small, short 30-second statement, and then we're going to have a back and forth. If it goes well, we'll keep doing it. If not, I'm going to move it to 250 each, or 230 each, 2.5 minutes each. But for now, we'll start with open conversation with your first topic. Go ahead, Brian.
Okay. Let's see. My first one, I'm going to say, I wanted to see some demonstrations for the way you were just describing that radius, with the refraction. Like a demonstration would be nice. I showed the fish tank demonstration and how that works for a flat Earth. If you could show me refraction demonstration for a globe, or if you could just explain the radius, the way you just described it, as applied to that white light on the warehouse floor. If you could apply that explanation to that white light that's about 3 inches above the floor in line of sight, that would suffice. Or any demonstration.
So in this part, where I thought you were going to be bringing something, you're asking me to bring something?
Well,
you brought the topic.
You just brought the topic.
White light.
Okay.
And yeah.
I didn't prepare anything. I prepared 6 things for my topic. I got links and web pages and stuff to show. So I don't have.
Right. Well, show me a demonstration, or just explain a demonstration of a refraction, not just numbers.
All right. So if you, I'll give you a little more detail in the temperature gradient there. So you can read about this on I don't remember the name of the page, but it's from Andrew Thomas Young at San Diego State University.
Yeah, we might come back to that. It's a long video. Partway through. Yeah. So, on and on and on. What do you reckon of the format? Do you like this back and forth format? This supposedly
it needs tweaking, because, like, a lot of times Jaron, I think, was seen to be hurrying things along where there could have been more discussion between the two. And it's kind of like a point was brought up, but then Jaron just said, "Oh, move on, next question, next question," without giving them the opportunity to sort of really get into it a bit.
Or even explain, obviously, explain what they meant or something. It's sort of like, yeah. That's what I thought. It sort of got cut off a bit. Go on, Ella.
It's always the same problem you have in this situation. It's really easy to lie. It takes quite a lot of time to refute those lies. And certainly Jaron's not going to let somebody spend the time necessary to refute the lies, because he's going to want to keep everything moving along quickly to appeal to his not very long attention span audience.
Yes. Just give people the chance to have their short answer and then move on and not really explain it properly. Yeah, you can see that happening a bit. Depends how you set it up, I suppose. Now, just taking a moment for Paul has put out his clue for his mystery scientist today. So you can take note. I dumped in his letters, but you can see his letters.
And we have a guess that is correct out there too.
There you go, already.
Yeah, well done, Turing test. He is indeed Carl Anderson, Mr. Anderson.
Mr. Anderson.
I noticed he got that answer before you put your clue up.
Did he?
No.
Yes. He did. Scroll
back.
You
did too. Well,
okay.
Yeah.
Well, there you go.
Just after I said going live, but he would have seen your letters at that point, so I'd say he's making a guess from that.
Yeah. Oh, yeah, he did too. Well done.
Yeah. Got it, anyone? Well, What else? I do have something that. Oh, maybe we'll see. Brian did put another response to something that was said he later on, but put in. Matt put out a video, but it was not overly. Not a lot in it. What else have we got up here? So I'm just looking through my list of stuff I had. Oh, of course, we have our good old friend Mr. Lindsay.
Yeah.
To go.
And for those that don't think that Brian, Leakey, and Toon having a discussion is derpy enough, you can always go to the asylum and watch the review of the debate with the clowns at the asylum. That's even worse.
That's why I prompted to have a look, because when I was looking through the videos, there's about 4 or 5 videos on this one video. So
yeah, I know.
I think I'll start by watching the video first, and then.
And poor old Brian thinks he's done so well.
No, he was a bit all over the place. So far, he hasn't really got anything together, has he? Come on, Blue.
He's Brian's very proud of his performance. He DM'd me a copy of his take on it.
Well, they always think they've done really well, don't they?
Yeah, they don't understand what silliness they've said, really, I think. Not unusual.
Although I think I think the best thing we must have had just lately, and I haven't seen any of it, must have been Bev versus, was it Whitsitt?
Bev versus Whitsitt.
Bev and Whitsitt. Well, that would be a train wreck.
The one time that people say Whitsitt got it right. Or at least
that's right. Yeah.
Or at least was the least wrong.
Oh, yeah.
Yes. Well, I was going to have a little break. We have a little bit of Lindsay. So I've posted your bingo cards, guys.
Oh.
Your link to the bingo cards,
I have my bingo card.
Do I have
correct?
Top left hand corner is Kundalini on mine. So
I've got Kundalini in the center of the second row up.
So now I think this is a new one. I'm not sure, but he didn't post one last week, and I wondered if that was because of him thinking everyone would go to his Patreon.
I have one without Kundalini. I'm keeping that one.
You're keeping that one? Yeah. How many goes did it take you to do that?
No, only one.
Only one? Okay, good. Okay. Well, it's only a short one, so if we get in quick, we won't have to listen to it. It's only 14 minutes, so we'll see how we go. I have no idea what this one's on. Oops.
Yeah, regenerated. No Kundalini.
Oh. Gotta stick with one.
And I still got black hole in the center.
Oh, you'll always have black hole in the middle. That's how I wrote it. So, everyone will have black hole in the center.
Oh, okay.
It's deliberate. Okay. Let's see if this works. Tell me if you can hear it or not. Yeah, I could say you can see it. That would be better. Yeah.
Hi there. Welcome to the Tomb of Illumination.
Can you hear that okay?
Unfortunately, I can hear it.
Okay. That's right. Let's keep going then. You got bingo already? No, you didn't. I do not have a bingo card that has "Welcome to the Tomb of Illumination" as a row. Oh yeah, let's try. Keep going.
Just a quick video regarding the free energy we have within our earthly system and how you can all understand it once you understand the flat earth model. if you've been watching my videos, you'd get to understand the whole flat earth model and how the energy is created. Regarding the central vortex, the build-up on the metaphysical build-up of the magnetic fields on the southern side of the tropic Capricorn and the northern side tropic. This is a donut. That whole it's a donut with the center core there, where creation is, that is creation. That then creates our created realm, the realm we live in. We cannot get into that space there. So it's a donut all the way around. There's the south build up here and the north here. So from there, from the Tropic of Cancer to the Tropic of Cancer all the way around, there's all the centre north pole, you could say, and the south pole all around the perimeter. Well, so you might want to check out my earlier videos so I don't have to go too deep. But it's
say that if you remember it.
It's what's happening up through the middle here. Get another coloured pen. You've got the hydrogen molecule, energized hydrogen molecule coming from the subterranean ducts that have come down via the plasma sun that's created back here. It's a long story. You need to understand the whole flat earth system. It gets dropped down here, it's sucked under the earth and comes along and up through here, right?
In ducts.
And at the same time we have the system coming up here, flowing down here, along here, flowing down here. And there's some, because the hydrogen molecule, as it rises up through the tropics, through the atmosphere here, it's expanding.
Oh, I can expand.
Okay, so you've got to imagine this gap in our physical realm is a blown up image of what's created back here.
What type of gap is it, Lindsay?
It's created like a vortex.
It's
basically showing us here how the molecule is expanding. Everything expands as it rises, and then it gets shredded. So the hydrogen molecule is coming up through here, expanding in the atmosphere. Is where science gets their idea of space, because it's just getting less and less pressure and must go into a vacuum, which is basically what it's doing.
Expanded molecules.
Going into a vacuum is how we know it, and it's changing its states as it goes up to the layers through ionisation and electrical storms, all sorts of stuff in the tropics here. This is all described if you look into tritium and deuterium. Okay, so I thought, well, this tritium deuterium, they must be bonding that to create this nuclear fusion, which is what they are. So you think there's a bonding. There's all to do with the hydrogen molecule that I've explained, and they've got all their science terminologies, which I don't know too much about. I just know in practical sense how it all works. So I know what they're up to. So he comes up here, and there's a bonding here. And this cross is also described in religion, because the religious story is all physics.
Just drew it, therefore it's there.
And astrotheology, they're sort of telling you, long story, but anyway, there's the cross. So there's a bonding. When this is coming up here, you can get this bonding through here. Once it all becomes shredded, the hydrogen molecule is shredded, separating it.
But you said it's expanding. How can it be shredding and expanding at the same time?
Tritium, and there's other forms of the hydrogen, isotopes they call them, isotopes, and there's bonding. It ends up getting flowed over to here into the actual real sun, the plasma we do not see, in this tight magnetic field. Well, I'm just sitting there trying to figure out how to get my free power from the atmosphere and the earthing, and look what I came up with. Well, let's draw a picture. Bad art, but What does that look like? And let's say the stem comes off and goes down here.
Looks like a daffodil.
And there's the ground. And then you go like this. Well, there's nature right there, right? There's nature. Well, what you do, this is the North Pole. Just like I've shown here, the centre north. Here's the south. South is in many places. Because all a reflection of the north. It's just the opposing pole. It's the returning field. It's that you could say that's one magnetic cycle. One magnetic cycle. 2-to-3 ratio, or a Fibonacci, or a golden ratio.
What?
They're all close enough.
Close
Not
enough.
close enough.
Close enough.
Oh dear.
And what's this
isn't
down here?
government work, though.
Well, in nature, what do we have? We have in celestial bodies, we have the sun. There's the sun. So I could say there's the sunflower. Well, where's the moon? There's the moon. This represents the moon. The leaf. It's the harmonic oscillator. Everything is about resonance, frequency. In our realm.
I've got to add frequency and
That's
resonance.
what gives us the colour spectrum. And what's the sun? The sun is the hermaphrodite, where the two forces of nature come together. You have a force that comes up here off the earth, the magnetic field. Then you have the electromagnetic force that comes over into the sun this way, created between the two capacitor plates of the tropics. So there you have this one come out and meets there. This is the Milky Way. Like the octopus. There's the sun. They come together and meet. And just, which is actually the black hole there too, and it creates the black hole.
Bingo!
Once the plasma is created, it creates the...
You're waiting on the black hole in the middle.
I've got bingo.
Oh,
I will share
God.
it and verify it.
sure, yeah.
Give me sharing permission.
Hey, is it? Get in there. They're back. Ah, shit. Well, don't share. Just share. Let other people share. There you go. Let me switch over so we can see.
All right, here we go. There you go. Just to verify that I do actually have bingo on the diagonal.
Okay. On the
We
sun,
have Milky
yes.
Way, system,
definitely
black
said-
hole, sun, and realm.
Yes, he definitely said all those words. So
He did. There you go.
There we go. Bingo. There we go. You mean we're not going to find out how to become rich with all this free energy now? Oh, Paul.
Well, I thought that was the point of free energy. Nobody could get rich off of it because it's like free.
Yeah.
Yeah,
If
but
it's free, you're not going to earn anything from it, right?
Make a fortune selling free energy. Okay. All right.
well, he's trying to make a fortune by selling free. Yeah, you got to pay his $500 and he'll tell you the true secrets. Anyway. Yeah, I think he's looking a bit down. I don't think anyone's joining his Patreon account. He's a little bit depressed.
Do you really think that anyone would? I mean,
I just don't understand how he has so many subscribers.
there's just not a market for paying for derp like that.
No, not for paying for it.
Why would you pay for derp like that when you can get it for free?
Well, 6.8K, which is not too bad for subscribers, but I think he's been on that for a while. I don't know.
Yeah, but I mean, still 6.8 thousand.
Yeah, well, that's pretty
6.8
good. I
thousand
mean,
subscribers. I mean, that's
at least my 78 or
not
whatever.
bad,
I've
is
got.
it?
At least my 78 for shame, isn't it? So,
And I
Yeah.
think they
Well,
all
well,
they all joined for the same reason that we watch Lindsay, to laugh and poke fun.
That's right.
Yeah.
yeah. Yes. Yeah, so there you go. That's our Lindsay for tonight. I got to check, Paul. Have we got a hard quiz tonight?
Yeah, I do have one for you, actually.
Okay, no, I'm
Yep.
just putting together what we're doing.
Yep, sure. Whenever you want it, it's all ready to go.
I do have Pete. He's going to play this. You know those Pete guys. I can't remember their names.
Peter and Pete.
Peter. Yeah.
Pete and Peter. Yes.
Be a brain box in order.
Who are going to tell us about why science thinks light is a wave. I thought that might be interesting. Let's see where it goes.
To understand
why science think light is a wave,
science,
did you say?
Light is a wave, yes. Obviously, they think they're wrong.
It might help if we could see it as well, of course.
It could, yes. So, there we go.
You know, it's very, very straightforward. Okay. Now, we don't need to play the audio because we don't need to.
Because that's one thing that I'm not sure about, and that is, do they actually, like with when they produce gamma rays, X-rays, for example, do they again? They probably do use direct current, but it's got to be pulsed, and then they transform it because they've got to increase the voltage. Yeah. So it's got to be pulsed to experience for the voltage to experience induction. Yeah. But we're only showing people this example of how they produce.
Did that make sense to you?
No, word salad. For the voltage to experience induction? What does that mean?
And you got to put more, and it depends whether you got AC or DC. So,
did he just? What did he just claim? Induction has to be induced. Is that?
Yeah.
What they're trying to do? Accelerate electrons in a big electric field so that you get the big. Oh, that German word that I can't pronounce. Type of radiation from when the electrons. That's the one, Paul. Thank you. When the electrons run out of vacuum tube to go flying down.
Yeah, they accelerate the electrons to a very high speed, and then what they do is they slam them into a piece of metal. What do you think that does to the electrons?
Makes a mess out of them.
It makes them stop very quickly.
Yeah. Oh yeah.
Yeah. That's called.
It makes the stuff they run into say, "Ouch."
Yeah, that's called an acceleration. And when you accelerate charges like that very quickly, they emit radiation. Yeah.
Mm-hmm.
Well, let's see. Go on to what else. Go on.
That's all an X-ray tube is.
Mm-hmm.
It's an electron gun and a target.
That's pretty much it.
Yep.
Get them going quick and then stop them bloody fast.
Stop them as quickly as possible.
That's it.
Yeah. Yeah, they usually make those targets in an X-ray tube out of tungsten.
Yeah. Oh, we're going. We'll see where they go.
Produce electricity so that people can understand your normal lighting, how the lighting is pulsed. Well, alternate current mainly, isn't it? How that's pulsed. Yeah. So I mean, so we've got a little diagram here.
So, do you guys have any direct current lighting, like a torch or anything, or an LED light or anything like that? Obviously, can't be real light.
Of course,
it's not pulsed.
Well, I mean,
you called it alternate current.
It's alternate. No? What? It's an alternate current to the ones that you're aware of, rather than DC and AC. It's an alternate current.
Animation here, and as you can see, if you look carefully at the arrows that are on the coil that turns, okay, you can see that the yellow arrows switch direction. Every time they go round, they switch direction, and then they go back again. And essentially, this is what happens in your electricity supply in your home, because you're generally supplied with AC current. And they use an AC generator in order to produce your electricity. because you've got steam, which powers a turbine. So you've got mechanical energy transforms into electrical.
Timbo?
Yep.
I mean, I suppose it's a minor quibble with the animation that they're actually looking at, but you know, the vectors for the current flow should really be getting bigger and smaller as it comes up to top and bottom in a sinusoidal type movement.
Yeah, I mean, I think they're just showing direction, not actual magnitude, though, Alan. They're just showing the direction of the current.
I appreciate that. It's it was just pedant mode in my head switched on for a moment there.
Yeah. We could go.
Energy. This is how they do it. So you're going to get current flowing in one direction, and then it will stop, and then it will flow backwards in the opposite direction. Stop, and then it will flow back in the opposite direction.
Which is why they call it alternating current.
Which
because it alternates in direction.
Because of the wires cutting the magnetic field. Yeah, get it? It's very straightforward. We can see it in this diagram here.
So
animation.
But people have to remember that AC is used to supply households throughout the world. Absolutely, of course, throughout the world. So a lot of lighting is dependent upon AC electricity.
Now, I've just got to show people, I think we should show wave. I'm just going to go on there. Here we go. Just going to look at wavelengths. Okay, so everyone is very clear on this. Okay, it's very easy to understand. We've got to go over this because then everyone can understand why we think science thinks light
is a wave.
That's all. But this is a typical kind of wavelength that you'd see
sine wave
on an oscilloscope. Okay, so the horizontal line is basically no voltage. There's no voltage there at all, and on your y-axis, that's where your voltage would increase.
Your amplitude.
Yeah, of course. So essentially, think of the wire as it's turning around in the magnetic field, okay, and it starts off where there's no voltage. So it's starting off from this point here on the y-axis. Yeah. Now, as it turns, it's generating a current, so that will increase and reach a point whereby
reaches the highest,
and then as it's moving away, I think as it's moving, it will come back down to zero because it stops. Yeah, which is at this point here. Okay. And then because it reverses, you'll get the wavelength going in the negatives.
Yeah.
Okay, because it's reversed. Yeah, we saw it earlier in the diagram.
Yeah. Is it alternating current? If you're trying to draw what they're saying, you wouldn't have instantaneous and a continuous slope. Would it be more of there'd be a period there where it'd be zero for a bit and then increase again? Yeah.
Just after I asked you to stop last time, that when they then described what was happening in their stupid word form, what they were actually describing was a square wave, not a sine wave.
Yeah, that's what I was thinking. That's what I was sort of asking.
Well,
was it more of a diagonal than a square? But do you know what I mean?
Good damn luck fashioning a rotating generator that produces a square wave.
Yeah.
Good luck.
That would be a miracle indeed.
Yes.
Yeah. I mean, that was why I objected slightly to the animation, just flipping it around, because that would show it as a square wave, not a sine wave.
Yeah. So, would you describe the current as a sine wave?
Yeah, it's absolutely sinusoidal.
Yeah. Okay. Well, there you go.
Both the voltage and the current will be sinusoidal.
Okay.
Well, yeah, careful.
Well, there's a good chance there'll be a phase difference between the current and the voltage.
Yeah, good chance you get all kinds of distortions in that, but
Okay. We'll see where we go then. Let's go.
In the animation.
So really, the wavelength is only really corresponding to the generation of the electricity.
Yeah, the wavelength only occurs because of the generation of how man generates electricity. This is our point. The way.
So light is only generated by man. Is that what we're coming to here? That's the only type of light we can check, measure.
Wavelength only refers to how man generates electricity. Yeah. Okay. Very straightforward. Now, when we go back to our electromagnetic spectrum with our wavelength, okay, think about it logically, okay. The way man produces electricity means he can have a wavelength. Because it's pulsed electricity. The electricity's on, and then it's off. It's on, off very quickly.
So it's dependent upon.
So if you increase that wavelength, if you increase the frequency, if you increase the frequency of those on, off, the interrupter going quicker and quicker, you can produce higher energies. Okay. Or I suppose if you're using high voltages, you have to do it very quickly.
So if you can spin that generator fast enough, you'll go from the visible light to infrared, is that right?
Well, no. I mean, you're spinning that generator, you're creating electricity. You're not creating an electromagnetic wave.
No.
There's no correlation between the generator and light.
No, I know.
If by chance your generator decides to emit light, my suggestion is run.
Yeah.
Nothing good is going to happen.
Particularly if you haven't put a light bulb in there. Yeah.
Oh,
dear. So much unexplained by that. Anyway.
Yeah, but I would probably go with that.
Yeah, in order for you to produce your gamma rays or your X-rays as such. Okay, but
there you go. See, Paul, you're obviously incorrect about X-rays. It's just you got to
think about it this way, Timbo.
You've got to turn it slower. Go on.
Think about it this way, Timbo. The formula that relates frequency, wavelength, and speed is the frequency times the wavelength equals the speed, right?
Yeah.
So if you're talking about electromagnetic radiation, that speed of light is about of the order of 10 to the 8 meters per second, right?
Yeah.
3 times 10 to the 8 meters per second. So you now got to divide that by the wavelength, right, to get the frequency, and that's how fast you'd have to change that and make that wave go. All right. Yeah. But the typical wavelength of light is anywhere between visible, anywhere between about 400 and 700 nanometers.
Yeah.
Right. Just times 10 to the minus 9. So if you bring that back to a single digit, that brings it back to about 10 to the minus 7. All right. And then you divide by 10 to the minus 7. You divide 10 to the 8 by 10 to the minus 7. You get around about 10 to the power of 15.
Yeah.
So you're going to have to oscillate those little electrons at about a frequency of 10 to the power of 15 cycles per second to get visible light. Good luck spinning a generator that fast. I mean, no taco built on Earth is going to register that.
Yeah, I thought that was. I want to see
so
if they get any better.
We can understand why. From that, we can understand why science says that electromagnetic waves, are what they are. Electromagnetic waves.
I was going to say, science says electromagnetic waves are electromagnetic waves.
Yeah, funny about that.
Funny that, yeah.
We can understand that because of the way man produces electricity.
And we also have to remember that man always will use equipment, devices like oscilloscopes.
Sure.
And oscilloscopes are designed to identify waves.
Absolutely, of course. I think we've done. We're quite happy with that, aren't we?
Yeah.
I mean, everyone should be able to understand that. If you can't understand that, I mean, I won't be speechless, but I think you've been totally indoctrinated.
Yeah, well, there you go.
Oh, yeah. Oh, an oscilloscope, which traditionally, of course, accelerated electrons into a screen covered in chemicals with a phosphorus
Yes.
type chemistry to make the light.
Yeah.
Yeah, same with the way the old TVs worked. Yeah.
Yeah,
Exactly.
They just do it. TV designed to leave an image behind.
Now, what does that sound similar to? Accelerate electrons and then slam them into something so they stop. What might that produce?
Oh, yeah.
What might that produce?
But so you're not suggesting we get right up close to the old cathode ray tube, do we?
Yeah, which is
those old color sets would produce some X-rays.
Yeah, exactly. Soft X-rays. Yeah.
Soft, very soft, but because
Yeah.
the accelerator voltage for those things was around 30 kV, 35 kV. Black and white didn't do it. The voltage is too low. But in a color set, the anode voltage was very high. And that's on the low end, actually dangerous end of X-ray.
Yep.
That stuff doesn't penetrate. It goes inside you and bounces around and tears up shit.
Yes. I do notice X-rays are so much easier now, though. I had to get my X-ray done on my hand, and it was in and out in a fraction. Because they don't, obviously, with the new digital stuff, they don't have to get the old plates out. And they still run away and hide, as you expect, of course. But
Yeah, of course you would. I mean, when I worked with the radar, if for those of us that had to work in the transmitter hall with all the transmitters running, we actually used to have to wear film dosimeters because lots of very fast accelerating electrons that we now don't need anymore. So we just let them run into stuff.
Yeah. I do have a little 5-minute thing that Mr. Leakey put out after his thing. I don't know if it makes any much sense, so I'm not sure if we've covered this bit or not. But
does anything Brian Leakey put out make sense?
No, not really. It's supposedly this is how you expose MC Toon. So let's see where it goes.
Should be shining this way. Problem is, the sun is now way down here.
Can we see it?
Can we see it?
Yeah. Now, was this something that discussed in? Maybe we haven't done this bit yet. Maybe I need to go where they talk about the light approaching the moon. It must be later on in the video in the MC Toon debate. So anyway, we'll see how it goes.
So if you raise up the moon half a degree, you would raise it up 2,000 miles, which is not. I mean, it kind of would help, but the sun, if you raise it up half a degree, you'd raise it up 800,000 miles. So
let me break this down. This is the excuse Toon uses for the top of the moon being lit when it's high in the sky from a sun sitting 1 degree above the horizon. Okay, because the moon, remember, can only be 240,000 miles above us at its maximum. So they show us this trigonometry where a sun 1 degree above the horizon is actually 1.6 million miles above our feet and like 1.4 million
above our feet
miles above the moon. So, but then they'll simultaneously try and use it as a proof with the sun sitting barely above the horizon, shining up on the bottom of clouds or casting shadows on the bottom of clouds. So you can't have
just a second.
Yeah.
Oh, sorry, it's all right. Yeah, I was going to say sun down there 1 degree above horizon. That's not the direction the sun is. But then I just noticed at the top.
It's looking up at it. Yeah,
which is correct. Which is correct, of course.
He's trying to use it like a sextant, but we'll see where it goes.
Have both. You can't have a sun sitting above the horizon, shining downward on the moon, and upward on clouds. This kills parallel sun rays, which in turn kills the globe model.
It was thrown at me that the sun putting a shadow up on the bottom of clouds or lighting up the bottom of clouds was some kind of proof for a globe, when in my earlier I showed how it works just with atmospheric lensing. But if we're going to use the trigonometry, if a sun is 1 degree above the horizon, that means it's 1,600,000 feet approximately. 1,600,000 miles above the tangent of my feet toward the horizon. So it's way above the clouds.
No, that's where you're wrong, Brian.
If a sun,
Stop.
He's got that out.
The tangent to your feet doesn't go to the horizon, Brian. You idiot.
No.
I've showed several, but I've showed the sun up to like 4 or 5 degrees, still lighting up the bottom of clouds. Now, how can a sun that's millions of miles above that cloud be casting light on the bottom of that cloud?
So I example a sun 1 degree above the horizon, and after I show him the trig, he calls it a negative angle. That's called a bold-faced lie.
No.
Because it's not millions of miles above that cloud. That's easy.
Okay. So you disagree with the trig that a sun 1 degree above the horizon, okay, 93 million miles away, puts the opposite side at 1,600,000 miles? You disagree with the simple trig?
You did not show any trig, so I'm not going to agree or disagree to any trig that you're referencing.
So he can't address this, folks. They can't, and they won't.
They can. He just
says, well, you ain't showed any trig. So then I pull the trig, and then he just starts describing something underneath the tangent, like something I'm not even demonstrating. It's like talking to a donkey.
I've not seen it to agree or disagree with it.
All right, I could pull it real quick. I thought we were going to keep this honest.
So you're showing the trig right now for your distance above the tangent? Okay, I'll send it to Tim. For distance above the tangent.
So Jaron just looked at it. He understood it. Angle above the tangent. Why didn't Toon understand it? So I must have asked him 5 times, describing a sun 1 degree above the horizon. And he calls a sun 1 degree above the horizon a negative tangent. That's all he could do, because he knows where it's heading. That, my friends, is blatant lies.
Okay, so if I go up above the clouds,
the sun is below the clouds in this instant of when you're talking about the tangent there. The sun is below the clouds.
So if I go up above the clouds, then the sun's going to follow me up, right? So if I go up 1,000 miles, the sun's still going to be at a tangent of my feet, right? It's still going to be 1 degree above the tangent of my feet, right? Way above the clouds, right?
It was never above your tangent. It was always below your tangent. It was never above your tangent. It was always below your tangent.
So no matter how crystal clear I describe a sun 1 degree above the horizon, he keeps calling it below the tangent. That's how you expose a liar.
I'm on the moon and I have the same exact angle damn near as I had on the ground. A 1 degree shadow casted. I put a 1 meter stick in the ground. I've got about a 28 meter long shadow casted down 1 degree. If I go up 20 miles above the clouds, I've still got a downward 1 degree shadow, right? If I go up 1,000 miles, I've still got a downward 1 degree shadow. And you're disagreeing with the freaking triangle calculator?
It was never above your tangent. It was always below your tangent.
There you have it, folks. Clinic number 1 on exposing MC Toon's lies. More to...
I suppose I think he did a good job of that, but that's just so silly. I suppose what else do we expect? What's the time? Paul, would you like to do a hard quiz?
Yeah, why not?
Why not?
We could do that.
You got sharing rights, so
let me get that organised. Slideshow from the beginning.
I find that works best. Question 1 first always tends to be.
What's that?
Doing it from the beginning always seems to work best.
It does, doesn't it? Yeah.
Yeah.
Here we go. Here's that. There. I had one blank spot left to fill. Doesn't matter. Okay, you ready to go?
Is Alan suggesting you leave it there while you go off and find one?
No.
No, that's you doing that.
All right.
Go on.
Here we go then. Question 1. Ernest Wallace Budge got around an export ban on these things by labelling 800 of them as a type of manure. What were they?
Type of manure. That's going to say tobacco plants. But
nope, not tobacco plants. Prince Albert enthusiastically responded to a request to raise more money for seeds found with these objects after being shown a demonstration by the author of Proverbial Philosophy, Martin Farquhar Tupper. What were they?
Oh,
not tomatoes, not Led Zeppelin, not Tropical Gaps.
Sliced eggs.
During the Great Depression, con men did good business selling grain supposedly found alongside these objects. Deep Purple cock rings. No. Fleetwood Mac albums. No. But we do have a correct answer out there.
Okay.
Public demonstrations on these objects were a big hit for Giovanni Battista Belzoni. This is an egg.
I'm a little bit influenced by the answers now, but let's get going.
Yeah, I know. English tourists inspired by a travel book that chronicled a 1,000 miles river journey by Amelia Edwards would often return home with cartonnage from these objects, which contained these things.
Yeah.
Oh, you get in trouble for doing that these days.
You would, yeah.
These objects often contain small amulets found in between the layers. You know what they are now, don't you?
Yeah, yep.
Yeah. Thomas Pettigrew oversaw numerous unrollings of these objects. Name these objects that may have had some of their insides placed in canopic jars. As Carl Edwards said a while ago, they are.
Well, mummies, yeah.
Mummies.
You stole that book.
I did. I thought that was too good to let go.
Put that one up.
Egyptian mummies. Yeah.
Yes. I do remember reading something where they were selling the bandages as some sort of cure for making you live longer or something like that. I couldn't remember what it was.
Oh, really? Well, it didn't work on the mummies, did it?
No.
No. Okay, question 2. NBA Jam developer Mark Turmel claims he shot enough footage to film a lost movie in this franchise for the failed Nemo console.
Oh.
Space Jam. Not Space Jam.
No. Okay.
No. The first film in this series was the highest grossing film for a director who created WKRP in Cincinnati.
No. Keep going.
Not level.
No, definitely not level.
No. Boxer Tex Cobb and a team of ninjas must be defeated in the conclusion of the 4th film in this franchise, whose poster depicts its high-speed balloon chase.
It would be it's a Jackie Chan film?
What?
Is it a Jackie Chan film?
No.
No, okay, different one.
Not Flat Earth either.
No.
The sixth and final sequel in this film series centers on a Russian mob. Bosses plan to use an addictive video game to somehow defeat computer security networks. No.
High speed balloon. Oh no!
You'll get it in a moment.
Anything.
It's not Spaceballs, but
No.
Michael Winslow. You know who he is. Did wacky sound effects as Larval Jones in these films.
Police Academy.
That's the one. I knew that clue would give it away.
Yeah.
Not Rocky, no. After Bart gets caught stealing, Homer tells him that he didn't take Bart to these films for fun and that you didn't hear anyone laughing, did you? The first film in this franchise that's supposed to be centered on Steve Guttenberg's character, who is forced to the title institution as a punishment for being a repeat offender. Name this ostensibly comic series of films about characters training to be cops. It is indeed Police Academy. Yeah.
Good day, Matt. Yes, I remember seeing when the discussion was Police Academy was the highest grossing film for a while and didn't make it to the Oscars, and people commenting on what people were actually watching.
All right. Here's an easy one. An early computer for predicting this phenomenon was nicknamed Old Brass Brains.
Phenomenon. Don't know.
Aristotle was a bugger with a bottle. Supposedly killed himself in Chelsea because he couldn't figure out the logic behind this phenomenon.
Yeah, I'm going to have to go with Carl Edwards and say ballistic trajectories.
Not ballistic trajectories, no. One analog computer for predicting this phenomenon was designed by Lord Kelvin after conducting a harmonic analysis of this phenomenon with the help of the Almanac Office.
Tides?
What?
Tides?
Tides is the correct answer. Along with
yeah.
Turing tests. You got that right. Yes.
Yes.
Yeah. A 1738 contest sponsored by the French Royal Academy of Sciences on this phenomenon was won by Daniel Bernoulli. Variables such as LAT, HAT, and MSL. I wonder what MSL stands for.
Made up sea level.
Are data points on the chart datums used to show the phase of this phenomenon. The original title of the dialogue concerning the two chief world systems by Galileo was named for this phenomenon. Yeah. Newton's Principia helped show the influence of the sun, causing the neat variety of this phenomenon. Yeah. Name this natural phenomenon caused by the gravity of the moon. It is the tides. Yeah. Tidal forces. Yeah.
Latin hat are both low and high tide. Low average tide, high average tide, from memory. Is that correct?
Okay, question 4. This man once floated the idea of a gilded suicide emporium in Paris where people could kill themselves to the most beautiful music.
Okay.
Yeah.
Eiffel.
Paul McCartney?
No. This man's heirs fought over where his official home was in a will drafted without the aid of lawyers that left the heirs only 0.5% of his fortune.
Nathan Oakley, no.
Nathan Oakley. No. On Friday evenings, workers leaving this man's factory put on special headbands so they wouldn't lose their tolerance for a certain compound over the weekend.
Ah.
This man moved from France to San Remo after being accused of high treason for allegedly stealing the recipe for poudre bee from Paul Viel and then selling his version of it, ballastite, to the Italians.
Well, I'm having a feeling it's something explosive, but like
Not de Gaulle.
It's not Nobel or something like that, is it?
This man brought the Beaufort ironworks in 1894, transforming it into a prominent manufacturer of cannons.
That will be Alfred Nobel then.
Yeah.
It will be. It will be Alfred Nobel. Well done. Yeah. This man's most successful invention was slightly modified by J.M. Willard to form a new product called Hercules powder. In 1865, this man designed a special cap for improving the safety and predictability of his best-known product.
Dynamite.
Yeah. Identified this inventor of dynamite and namesake of prizes awarded in Stockholm. It is Alfred Nobel.
Nobel.
Yeah.
You know what, Paul? I've actually used the products of Alfred Nobel and J.M. Willard because I've used the Hercules powder as well.
Oh, okay.
Oh, yeah. I haven't.
I don't know what kind of powder it was that my cousins used when they were little, but they had a can of blasting powder and they'd built this cubby house beside the river. And inside their cubby house, they had a little campfire. And they decided they were going to start throwing little handfuls of blasting powder on the campfire.
Oh, no.
And it would just go fizz, fizz, fizz and make, it wouldn't explode. It would just fizz, which pretty much is what it does when it's unconfined. But then they set the whole can on the fire. One of them ended up seriously injured in hospital, and the other one had pretty much no hair, eyebrows, or eyelashes left.
As far as I'm aware, blasting powder is actually usually good old-fashioned black gunpowder.
Yeah.
I have used black powder. I haven't used Hercules powder.
Yeah, I once had a friend who wanted to get rid of some nitrocellulose-based propellant powder, so he poured it out onto the the concrete in his tiny little backyard,
right,
and then set the whole half kilo on fire.
Well, that would be pretty spectacular.
Spectacular.
Let's just say the flame was over 6 feet, over 1.8 meters high, and I could only get about 4 feet away from it because he called me in the corner when he threw the damn match on it.
And it got the attention of the neighbours probably too.
Yes. Draw attention, yes.
Okay, question 5. After the release of an Errol Morris adaptation of this man's best-known book, he falsely told Playboy he was going to cut down on public interviews to stay focused on his work. Who was it? Not Lindsay Harris?
No. Awesome.
John Gribben secretly polished up that book by this author. This man was sampled on Pink Floyd's 1994 track, Keep Talking. If only Farmer's Boy was here.
I was going to say Farmers would get it now.
This author's daughter has written children's books such as George and the Unbreakable Code, and her birth caused a revelation for this man in a biopic where George Nikolov plays Isaac Kalatnikov?
Oh, don't have any idea.
We have an answer out there I've been ignoring for a while, but I think it's right. Carl Edwards, you devil, you got it.
I was going to say, yeah, okay.
As Charles Seif notes in an unflattering reverse chronology biography, this man's main reason for hosting TV shows, such as Stem Cell Universe, was to finance his extremely high living expenses. Yeah.
Right.
Critic David Blum alleged that Bantam Book's decision to place a cover photo on this man's book was the main reason it became the best-selling non-fiction book of 1988.
Oh,
yeah.
Okay. Yeah.
This man once made a wager about the origins of Cygnus X1 with Kip Thorne. That would have given it away, right?
No.
No? Named this author of A Brief History
that would
of
have.
Time.
That would have.
Yeah, it's this man. Yeah. Stephen Hawking. Oh, dear. All right. Question 6. Madame Brillen was stuck in her tub for hours because Ben Franklin was too focused on this activity in her adjacent bathing room.
I hate to tell you, but no, it won't be that one. Keep going. There's a few things he was into.
The Nunes Cup was awarded to the winner of the first international competition in this activity.
Kite flying.
Not kite flying, no. William Lewis' treatise on this activity was already out of date by the time of its 1844 publication. Not generating electricity, not putting, not playing music. Howard Staunton served as a columnist for this activity for the Illustrated London News and designed a neoclassical set of parts for it that's since become a standard. In 1897, the British House of Commons competed against the American House of Representatives in this activity, ending in a draw. Not sailing.
I was going to say chess, but chess is
out there, though.
Is it chess? Because I thought chess was much older than that.
Yes, indeed, yeah. A 1970 doctoral thesis by Thomas Stroline examined KOK, KRK, and other endgames from this activity.
Yeah, well, that would have definitely given away.
Yeah, when trying to win their first telegraph contract from the government, Samuel Morse and Alfred Vail emphasised the device's accuracy by using it to play moves from this activity between two clubs in Washington and Baltimore. Name this activity played by engines such as Ribka, Ivanhoe, and Stockfish, as well as by humans such as Gary Kasparov. That would have given it away.
Yeah.
Idiot. Chess. Yeah.
I was thinking something much more recent, of course, obviously. But yeah.
Nope.
Nope.
Okay, question 7. In 1938, LA kindergarten teacher Helen Hulick was thrice barred from giving testimony in a burglary trial for this reason. What is the reason she was barred?
Because she was blind?
Not because she was blind.
Because she wasn't married.
Not because she wasn't married.
Okay.
Until the 1940s, police in Florence could seize a person's bicycle for this reason.
Didn't have a seat?
Nope.
Sorry, I didn't say that.
Not wrong colour, not because she was pregnant, no. Until 1989, the Eric collection contained an emergency object in the cloakroom to help researchers not commit this offence, which originated from a mandate from Helen Clay Eric's wife. She wasn't a flirt, no. Not the wrong colour.
It's a fence.
Evelyn Bross was charged with this offence in Chicago in 1943, despite her job working as a machinist for the war effort. Not she was having a period, Carl Edwards. No. An idiom about performing this action relates back to at least a 1612 John Harrington epigram. In 2016, British Airways relaxed restrictions in its ambassador uniform policy, forbidding this practice.
Would it be something like wearing pants, like trousers?
Wearing pants is indeed the correct answer, but you were beaten to it by Turing Test 2 out in the chat. He got it some time ago, which I was politely ignoring. But well done, Turing Test 2, for getting that. Yeah. One of a dozen or so special people granted permission to take this action in France in the 1850s was an animalia who needed to be able to take this action to head to the slaughterhouses and horse fairs needed when preparing to paint works such as ploughing in the Nivernias. Name this fashion statement that also idiomatically denotes the person who has the power in a relationship. It is wearing pants. Yeah. All right, question.
Or really trousers, isn't
it? Yes. Question 8. Anyway. One program with this purpose, authored by David Aubrey Jones and David Looker, began as a way to improve the load time from computer games distributed via cassette. What was the purpose of this program?
That sounds familiar.
Data compression.
What?
Data compression.
Data compression.
Nope. One system with this purpose, known by the acronym TMSS, was ruled to be illegal in a case brought by Accolade. Not Turbo Loader. Another system with this purpose required the user to spend a lot of time calibrating their TV before using a device that had a bunch of prisms in a plastic holder. That device was most prominently used with Elite for the ZX Spectrum. For what purpose?
Well, I know what it is, but I'm not too cool. I don't think I've got the name right.
A specialized piece of hardware for this purpose, known as the CIC, was copied in the Rabbit chip.
That sounds like DRM, as we would call it now.
What?
Digital rights management.
I think there's someone out in the chat that's got a closer answer.
Yeah.
The 10 NES system was developed for this purpose for the Nintendo Entertainment System.
That's copyright protection type stuff. Yeah.
A system of this type was infamously installed via a rootkit on CDs sold by Sony. A 2017 post on Steinberg.net affirmed that the latest version of music editing software, Cubase, still required a dongle that served in this capacity. Yeah. Circumventing software of this type is generally a violation of the DMCA. Yeah. Name this type of feature that attempts to prevent unauthorized use of hardware or software. It is, as Carl, who seems to be doing very well, this quiz. All right. It is indeed copy protection. Yeah.
Well done, Carl. I was in a completely wrong direction from the first one. I was trying to think of some sort of, like Alan, some sort of way of data compression, making it load faster. But yes.
Now, here's an easy one. You'll get this one quickly.
Okay.
Analyzing this experiment using wave functions is used to show that visibility squared plus distinguishability squared is less than or equal to 1. No? Okay. A wire grid does not affect the results in a version of this experiment that may violate complementarity conducted by Afshar.
It's not something like...
Not the Senyek effect, no.
It's not like the double slit experiment or something like that.
In this experiment, when the path length differs by half integer multiples of the incident wavelength, destructive interference occurs. A BBO crystal is used to generate entangled states in a version of this experiment in which there is a delay in obtaining path information.
Well, that's what I thought, Carl, but we'll see.
Carl Edwards thinks that you're right, Timbo.
Yeah.
In a version of this experiment, obtaining which way information leads to a change in the results. Does that confirm that you're right, Timbo, or not?
Well, I haven't seen anything otherwise. Yet.
Okay. Name this experiment that shows the wave nature of light in which fringes appear when photons are fired through two rectangular holes. Sounds pretty good, doesn't it? Yes, you're right, Timbo. It is the double slit experiment. Yeah. Young's double slit experiment, to be precise. Yeah.
I wouldn't have got the Young's bit, but I knew the double slit.
Last question. A quantity representing this force is squared in the formula that defines the Oswald efficiency number.
Okay. Is it the quantity of stuffle? No?
Nope. It's not electromagnetism, but a variant of the Biot-Savart law is applied to a horseshoe configuration in deriving a theory named for this force's line, which was independently developed by Frederick Lanchester and Ludwig Prantl.
I don't think it's density.
It's not density.
No, that's what Carl had.
No.
It's Clive had, sorry.
In unseparated and steady conditions, this force per unit length equals the quantity density at infinity times velocity at infinity times circulation, per the Kutta-Lukovsky theorem. Not air drag, not water drag.
Lift coefficient.
This force is generated by a difference between upper and lower camber, though not for the commonly cited reason of equal transit time. I think we have a winner.
We have a lift.
Yeah. This force's magnitude suddenly decreases above a critical angle of attack during a stall. Something you've got no what, Blue? Something
Lift
you've got
coefficient.
no what?
No lift.
No lift. Yeah.
Did you have to use this? Did you have to use the stairs?
Generate what force that acts in the opposite direction to gravity on an airplane in flight? It is this one.
Got no lift. Got to use the stairs.
Yeah.
Maintain thine lift, lest the ground rise up and smite thee.
Yeah, that's right. And that was your quiz for today.
Well,
there you go.
Thanks for that. That was really... Carl thought that was difficult, but he loved it. Well done. Go on to Alan. What were you saying?
I'm going to say the other one, fly in the middle of the air. The edges of the air can be identified by buildings getting bigger or the approach of interstellar space.
Yeah, I don't think anyone's really perfected subterranean flight yet, have they?
Subterranean flight, no. A lot of people are attempted, but they only get so far.
Yeah.
Well, unless we really are, concave Earth.
I decided the other day I was inverse concave Earth. That was any explanation made sense. Speaking of people who make sense, I've got a Gary Wabenga.
A Gary, why bother?
Optical compression. Why moving away becomes unsolvable first. Not that anything he says this makes sense. It's only 3 minutes, nearly 4 minutes. So make it so you can see.
Okay, I'm going to do a quick video. It's going to show why things like boats and buildings and anything else will become unresolvable bottom first. And why somewhere at the midpoint is obviously going to reach that limit before something to the top. So this is more of a mid-level. It only has to cover this distance. The top has to cover this distance to merge with the ground. As you move away, this angle right here, A, this is your angle over the ground. See, that's just, you can see it goes this way. Your angle over the ground. See how narrow it is here, but look how much more narrow it is over here. As my angle from far away becomes more acute to the surface here. So A went from 7.5 degrees close up here to only 2 degrees over here.
Never gets to 0.
Mm-hmm.
Never gets to
so
negative.
The ground is converging towards my eye level because of that very reason. Now B is this one. Just the vertex right here and the vertex right here. So B went from 15 degrees to only 3.5 degrees over here. So that is converging towards the center of my vision. And the ground is coming up towards that point. Everything will converge towards a line of sight.
And C is still 2 times B.
Because you're moving parallel away. So it's all going to converge. It's like railroad tracks.
It's not converging now.
So anyhow, C is this angle here, this vertex. It's how you see the whole building as a whole, which of course is much more than B. C over here is 30 degrees of your visual field. Over here, it's only 7 degrees of your visual field.
Wow, he's discovered a thing called
B,
angular size.
Like I said, B is only 3.5 here. Over here it was 15.
Yeah. Oh, okay.
15.
I mean, so far he's just pointing out basic geometry. He's not wrong in anything, but it doesn't actually explain anything.
It's like, yes, B is still half of C. You know,
all those angles are right, Gary, but they don't actually explain anything of importance.
It still hasn't seen any compression in that angle in the bottom in B than over B over C. It's still the same. It still should be the same. Oh, well.
It's going to converge. If you measure the whole vertex here versus the whole vertex here, everything is converging.
Yeah.
It's getting smaller over here compared to over here. But the bottom, from here to here, is going to disappear to that point faster than this whole thing.
No.
Why?
It's not, though. It's the same proportion all the time.
Hey, Gary, just a tip. This is a bit confusing. Can you do it with rubber bands, please?
Yes, C is obviously a much bigger angle.
Gary cannot comprehend the concept that the upper half of that object he's drawn remains the same size as the lower half of the object.
The angular size is consistent.
So the angular size, if your line of sight is at the center of it, the angular size of the upper half is exactly the same as the lower half. Why doesn't the upper half disappear, Gary?
And even on his calculations, B is half of C in both images.
Exactly.
Affects.
I think he claims it has something to do with A, though, doesn't he?
Well, he's trying to talk about conversion, but it's still proportional. It's still proportional.
Yes, we know it has nothing to do with A, but that's his claim, as far as I'm aware.
Well, A would have to at some point. A would have to have going below the the level line, if you want, whatever you want to call that line. It never does. It never gets to zero. Obviously, you can get far enough out that it's too small to resolve, but it both gets both B and C are staying the same and resolve at the same rate. So
distance, including things like Polaris. And then I'm going to do another video that shows how not all 10 degrees of space are equal.
What?
Kind of hinted at it in one of my last videos. But I'm going to show you why, just with a simple diagram like this. Everything works this way. We live on a parallel plane.
But you haven't shown anything with your dog.
So everything as we move away collapses, compresses, how we see it. Because we see it as we see the vertex. As it gets smaller, it takes up less room in our field of view. And it converges towards our line of sight.
Converge at a different rate, though.
I think you should stick to milking cows, Gary.
Yeah.
Yeah. Oh dear, poor Gary.
It doesn't really explain why you can still see mast and spars on the top of the ship that have got much smaller angular sizes than the hull. Does it? At whatever, assuming that you're using the same magnification.
Yeah, well, if you drew a ship in his picture there, you can say what point does the bottom half of it change to the top half of it? And it doesn't. It's in his diagram, so yes, that's right. That's Paul. What else have we got to move on to? We could do. I don't know. I've got Mr. Sensible. He's talking to Flatzoid, but
haven't heard Mr. Sensible for a long time.
Yeah, I'll put a bit of that on.
Did I really pronounce it that badly, Clive?
Oh, what did you say you did? I don't get it. Okay. Copy. Turn, enter.
Why? You would agree because the star had.
Yeah, I'll push this one along a little bit because it was a long video. It's
yeah. Well, do you want to show us again?
No,
of course.
I like to keep you guessing. Here we go.
No, hold on a second. We're stood at that cross point, yeah?
Mm-hmm.
Yeah. So we got one ray going to the star.
Hypotenuse, yeah.
One ray going that way.
They're adjacent, yeah.
And there's our vertex. That's it.
Yeah.
That's two rays and a vertex.
The star has a GP on the ground, correct?
Yeah. Well, for a start, it's not there. The star's GP would be somewhere
around there. Exactly. That's why I look to the right.
Yes, like that. So that's how the star's GP would be. Yes.
Great. So would that change the angular reading?
No.
Why not?
Because the angle in both of those is between the red line and, sorry, I'm a bit colourblind, whatever colour that is between. What colour is that?
It's between white and baby blue.
Okay. So we got the line from the star to the cross, What we're measuring here is the angle between the red and the line from the star to the cross. What we're measuring here is the angle between the red and the star to the cross. The fact that the fact that the star's GP is there or misdrawn there makes no odds. All I'm interested in is that angle. Two lines and a vertex, an angle, as we established at the top of the show.
Of course, it makes a difference.
Why?
You would agree because the star has to be 90 degrees, correct?
What do you mean?
The star has to be 90 degrees on Earth's surface, just like you are 90 degrees on Earth's surface.
The star is, if you're stood here, it's 90 degrees. If you're stood here, it's not.
Exactly, but I'm saying, let's say you got someone standing underneath the star at 90 degrees. They'll
okay,
be on the
so
right.
we got someone stood there.
They're looking upwards.
They're looking
so
up,
the star's
and that
right
star's
ahead of them.
The star is right over their head. Yes. Okay.
Great. Okay, and then you got the observer standing on the top there.
There. Yes.
Also at 90 degrees.
To what? Oh, 90 degrees to the surface of the Earth. Yes.
Yeah.
Yeah.
Okay. So they each got their own different zeniths.
Mm-hmm. Yep. So person A has got a zenith that points to the star. Mr. Sensible has got a zenith that points just up there somewhere.
Straight up, yeah.
Yeah.
And you take a measurement now, let's say 45 degrees to that star.
What, me? Here?
Yeah.
Okay, so I have used my sextant through all our clever means, and I established that angle there. Yes.
Okay, great. Now I want to ask you, we're minusing the 90 degrees to get the co-altitude angle, correct?
Okay, so what angle were we saying? This was 45, was it? So this is 45 as well?
Yeah, but you're taking 90 degrees
yes.
of the star's GP.
No.
And you're minusing to get the co-altitude angle of the star's GP.
What's the co-altitude angle?
The co-altitude angle is the apparent angular measurement. So the apparent angular measurement, the correction of the apparent angle measurement.
No.
So if
no. Can I correct you?
If I take 45-degree measurement.
Can we say 40 so we get 40 and 50? We don't get two 45s, just to make it clear as to what we're talking about.
Okay.
Okay, so it's 45 degrees up.
You measured at 40 degrees.
Yep.
Okay. Now you have to take 90 degrees.
Yes, which is
and minus the 90 degrees by 40.
Yep.
Which gives you 50 degrees.
And where's that? That 50 is there, isn't it?
Yes, co-altitude angle.
Yes. So what?
Okay.
Just to
listen.
But I'll let you carry on. But just to explain. So what I've done is I have used my sextant, measured that the star is 40 degrees of elevation. Therefore, the co-altitude is 50, which is 90 minus the 40. I.e., that star is 50 degrees off of my zenith.
Great. Okay. So, does that star have a 90-degree angle as well?
That star has a GP somewhere.
Of 90.
Where your matey boy is sat over there.
And it will have the same circle of equal altitude.
What does that? What do you mean it'll have the same circle of each?
It has to have the same horizontal plane.
No.
You're completing a triangle here.
No, you're not completing a triangle.
Yes, you are. You're doing triangulation. You're doing
no, you're not.
You're doing Sakatoa.
No, we're not. Okay.
Yes, you are.
Okay, if you're doing Sakatoa, what's the height of the star?
You can't get the height of the star because
Why?
it's apparent. Because I've proven this with my
You just said you're solving that triangle with Sakatoa.
I can give you a citation that says you're doing Sakatoa if you want to.
Well, you're not. Okay, let me run you through what.
I can give you a citation that says you're doing Sakatoa.
Okay. Give me a citation. I suspect if you come across a reference to it, it's in a different aspect of it because you don't solve any. If you solve a triangle, if you've got two angles and a side or two sides and an angle, whatever, you can solve all the lengths and all the angles. We haven't got that. And anyway, we're not interested in solving a triangle. What we're interested in,
yes, you do.
Like my example, when I was on my spinny chair, all I'm interested in is how far have I turned around. I've turned around in this case 50 degrees. Therefore, that star is 50 degrees off of my zenith. Therefore, I know the percentage or the distance around the Earth I've travelled. That gives me a distance. I didn't need to solve any triangles. Oh,
there we go.
What, is that the one you're talking about?
Sakatoa.
Right, so what is this? Because I can't see what that says. It's quite small. Trigonometry, yeah. The three basic trigonometry relations that we're concerned with here are sine, cosine, tangent. They're ratios of length of two sides of a particular triangle. Particular type of triangle is most useful in maths is a right triangle. One angle equal to 90. Where's it saying about
celestial navigation?
This in relation to celestial navigation?
It's a whole document. This is just the one part on Sakatoa. You can go through the whole thing.
But we know what.
I'm just going to look for the whole.
Okay, because we know what Sakatoa is. That's the whole point when flat earthers say you're solving a triangle. Well, why can't you tell me the height of the star then? Because using Sokotoa, you can calculate those sort of things.
No, remember, if you can use Sokotoa to get my height of my floss, then I can say, but you guys can't get that right. You know,
Sorry?
no one has managed to do my floss challenge yet.
I don't know anything about that. I don't know anything about that.
Are you good with trigonometry?
I can muddle my way through it. I'm not going to be able to do stuff.
If I give you the
the point is this is solving triangles using sines, cosines, and tangents. You don't do that to get the co-altitude angle. The co-altitude angle tells you how many nautical miles away you are from that star's GP. That's it.
Mm-hmm. How do you get that co-altitude angle?
Well, we just done it, didn't we? We just did
it.
Yeah. Sorry, let me just... No, hold on. Where's your image? There's your image. Okay, so I measured the altitude of the star at 40, which deduct from 90 gives me a co-altitude of 50. It's 50 degrees off my zenith. So it's 50 times 60 nautical miles away to the star's GP. I haven't solved any triangles. I've got the answer.
You do know the 90 degrees you are working with is the star's 90.
What do you know? What do you mean? I'm stood here.
Mm-hmm.
Okay, I'm stood here. The star is 40 up.
The star is 90 degrees in reality. Otherwise, you wouldn't get
a star is
complete. Otherwise, you wouldn't get your complete triangle, would you?
I'm not solving a triangle. I have taken one angle, the measured elevation, and deducted that from another angle, from 90, to find out how far off of 90 it is. So if it's 40 degrees above horizontal, therefore by definition it's 50 degrees off of vertical. Boom, that's it. I haven't solved a triangle. I've done one simple subtraction. That's all I want to know. And now I know that. I know wherever that star's GP is, could be anywhere, because I don't know them off by heart, and it depends on the time of day, but wherever it is, I am now X nautical miles away from it. I'll get my nautical almanac, look it up. Oh, there's the location of it. I'm X miles from it. That's
okay. I'm going to ask you again. Remember, I asked you, are you good at trigonometry? So, if you measured 40 degrees to the star, okay,
elevation,
and we know the internal angle, some of a triangle is 180 degrees, okay.
Yes.
So you've taken the 90, you've minused your 40, which gives you 50. So that means it would be 50 degrees of the star, correct, in the corner. On the top.
But all we're interested, Zoid, is
listen, that would be 50, correct?
Right.
So there's your co-altitude angle without without minusing.
Do you know, I think I can see where you guys are all going wrong. You're just trying. You've got your first angle, the angle of elevation of the star, as you said, 40. You know that the star is at 90 degrees to the Earth's surface somewhere, and then that gives you the remaining number of degrees. That's what you're talking about, isn't it?
I might have to draw this again because this is simple.
Yeah, it's simple. I don't see why you don't get this. I mean, look, you see your diagram.
Simply wrong.
Okay. if that star, because of course I know it's just a drawing, so the star's very close. But if that star, okay, I'm at 12 o'clock. If that star was at 9 o'clock, right over here, okay, I mean, because it's parallel light, it would appear exactly on the horizon, wouldn't it? So when I measured its elevation would be 0. Deduct that from 90, it's at 90 degrees to my perpendicular. Therefore, its GP is a quarter of the way round the world. There, at 9 o'clock.
Okay, I've given you with all the angles in.
Oh, right, you've got another diagram. Okay, let's just see if I can get that one in. Nice. This one, yeah?
Mm-hmm.
Okay. Yes, that's true. But that's what I'm saying. I see where you guys are going wrong because I'm stood here on the right. I measured the star's angle as 40 degrees. We know that somewhere on the Earth, the star. Who do you reckon, Blue?
The real problem is I don't think Sensible understands why they're going wrong. And it's because if you stop drawing these damn triangles, then they'll shut up. That drawing is highly misleading. Those lines of those rays coming from that star are all parallel. That vertical line he's got drawn on the screen right now does not exist. That is just wrong. Yes. That's a line that's parallel to that hypotenuse in reality. All the light coming from the star, all the rays of light are parallel.
Yep.
And we don't help matters any by continuing to draw these messed up diagrams like this. You draw a triangle, and these idiots are going to grab a triangle and start playing with it.
And start talking about you can't have a curved tangent and curved adjacent and crap. Because it's not that it is, but misunderstanding the concept in the first place.
Yeah, as Carl Edwards says out in the chat, the diagrams like that are totally invalid. They are. They're highly misleading and totally invalid.
Because what throws it out is they, like Flatzoids, trying to say, oh, you have this triangle and you end up with the same angle over here, so therefore the triangle works. But no, that's just a function of 180 minus 90 leaves you with 90, which is the same 90 that you're dealing with over here.
Draw a whole bunch of parallel rays coming from some object. Don't even show the object, just show a whole bunch of parallel rays striking the ball, and one of them, only one of them, is going to be passing through the center of the ball. That's the GP of the star. The other ones are not. And one of those other ones is going to be the one that you see as the observer.
Yep.
I don't think we help ourselves when we draw these messed up diagrams.
No. And then you come back to, where is that GP on your map? Because you need to know that. And that doesn't work for them either, so. For the whole thing to work. Yeah. So it's still stuck on this, and we haven't even got to the actual working out where you are bit. So, yeah. I don't know.
Yep.
I think this obviously just goes on. The same sort of stuff. I know he goes on to talk about it, but yeah. I've listened enough Flatzoid on his misunderstanding of celestial navigation and keep claiming that he knows all about it, but he's never actually physically done it. So, and his only claim is, oh yeah, I did some of the calculations and I got 3 out of 5 close. And it's like, well, that's not really very good.
Clearly, none of the flat earthers have ever done celestial navigation, and they don't understand it. That goes without saying. Unfortunately, we got a hell of a lot of people on our side of the fence that have never done it either, and only have a rudimentary understanding of it.
Yeah,
and they're not very good at explaining it.
Because I remember watching a ship's navigator explain it, and he used completely different methods than what I've seen used. So yeah, obviously, how they do it is different. So yeah.
Well, you can show an approximation of the process with the 3 circles of equal altitude, all that good shit.
Yeah.
But that's not usually what a navigator does.
No, that's right. That's what he's.
That's not normally what you do. You get into the site reduction tables, which rely totally on spherical trigonometry, by the way.
So trigonometry, now that involves that delta symbol, doesn't it?
Yeah, it
does. Triangles, of course.
Yeah.
Triangles. That's why you have the delta signal, because it's a triangle, obviously.
But that is a common problem, Blue, and it doesn't only relate to celestial navigation. As an example, they were talking about refraction on Jim's server the other day. and there was someone in there that supposedly knows a lot about physics, was trying to tell me that refraction is because the cause of refraction, why light bends when it goes into something else, is because the light is absorbed by the electrons and then re-emitted.
What?
And I had to quickly yell out, no.
No. That is not it.
Yeah.
That is not it. The speed changes. I agree that, but that's not why.
That's not why. It's not why it bends. That was Grenade Head that was trying to spout that nonsense.
Oh, good grief.
Yes.
How would it know? How would it know which direction to get re-emitted?
Exactly.
Clever things, those little atoms.
Yes.
And
they keep track of where the light hits them, and so they know which side to spit it out on, I guess.
Yeah.
I mean, that works in stimulated emission, but not in just an everyday
Not
emission.
in ordinary.
No.
No, it's when you start mixing two ways together, you get some different answers.
I think, unfortunately, I think refraction can get people in trouble. I'm definitely not an expert on it, but you hear enough people sort of know that that's the answer to some of the questions, but they don't really understand it. Particularly when you talk about the black swan, you see that come up all the time. And so, like, you just stay away from the black swan. It's just, if you really know it, just leave it alone.
I mean, both sides have their liabilities, don't they? I mean, like, are there any flat earthers that actually really think that almonds of any use?
Yes. And every flat earth has their own different thing anyway. So I know we were talking the other day about how the flat earthers can't get together and come up with a unified theories. Sort of like, well, because they all believe different things for different reasons. Well, what have we got? Oh, I've got some Everett. I haven't done Everett for a while, and we've got a Dan. Let's play Dan. I haven't played Dan for a while. I got another Gary, but I think we've had enough of Gary. I got this one labelled X Flat Earther. I'm not sure what that one is. I'll put that one up. Let's see what that one is. Oh, okay. 25 minutes.
Hey everyone, how's it going? So I come across this video, Speak Truth, Seek Truth, and he's bringing a really old globe claim back up again. I don't know why ballers seem to do all this. I mean, it was debunked years ago. But I think what it is arguments are killing these people, so all they can do is keep rehashing old arguments. But this is what we have to deal with. So let's have a listen to what he's got to say.
Hello, welcome to Seek Truth, Speak Truth.
Who maybe doesn't know what the truth is.
Thank you so much for clicking play today. I'm an ex-flat earther and I use this channel to destroy the notion of my previously held beliefs.
Ex-flat earther? So you found truth and then you went back into lie. I mean, wow, that says a lot about your mentality, mate.
Now, the last couple of videos I've done has been a back and forth with Flatzoid, claiming to be a flat.
I don't really think they're a back and forth. Like, I think you made a claim and Flatzoid showed you a couple of year old video where he already debunked this.
But we've seen evidence before that he does fake things to get his results, and I have evidence here again that he has been caught using parlor tricks to try and debunk my claim, even though
parlor tricks, biggest parlor trick going is globe earth, mate. And why all this groundwork? Why character assassination? Why muddying waters? Why poisoning well? Why can't you just make your claim, show your proof, and there you go?
What he does nothing to debunk anything at all. It's not even relevant to my claim. But we will go through.
I'm seeing some serious projection here.
Through this, and we will show you exactly how dishonest these flat earthers are and the tricks they have to use to con people into believing in flat earth. So I've been showing this image here, which clearly shows a shadow being cast upwards into the clouds. With this evidence I'm now showing you in a demonstration I did, I have shown that the only way a shadow can be cast upwards is if the light source is below the object casting the shadow. So this is...
So only way you can get an upward casted shadow is if the light source is below the object casting the shadow. Is that what you're saying?
Yep.
Because I don't think you've got a clear understanding of how light works.
This is what Flatzoid needs to debunk. He needs to show me a light source above an object, and also then that object casting a shadow upwards whilst the light source is above it. If he cannot do that, his claim that the earth is flat has been debunked. So,
well, I don't really understand what shadows have to do with shape of earth, but I'm going to have a go at debunking your claim, not Flatzoid. Piece of paper for clouds. Piece of cardboard representing Mount Rainier. Torch from a light source from above. And as you can see,
reflecting off the
As we can see the reflection off the floor.
clouds.
Oh, what a numpty.
There's a shadow cast up onto underneath the clouds.
Yeah, the light source creating that shadow is from below.
Where is the light source, you dipshit?
Yeah.
A shadow can be cast upwards.
I'll take a crack at it. It's the surface of the damn floor, you knucklehead.
So, unless there's a big mirror in front of Mount Rainier.
If the light source is below the object casting the shadow.
So that sun's way up there above my window. But yeah, I'm still getting a shadow on my ceiling from lampshade.
The only way a shadow can be cast upwards is if the light source is below the object casting the shadow.
Oh dear.
That sun's the opposite side of the flat. See its shadow there. But yeah, there's still a shadow from lampshade.
Is the window below your light shade, dude?
The only way a shadow can be cast upwards is if the light source is below the object casting the shadow.
There you go. Oh dear. That one's a bit sad.
Very sad.
Well, I have set up my own quiz for tonight. I'll definitely finish up early. So I'll be working on my little WhatsApp program. And I've taken into it the complaints that I got from last time.
Okay.
Okay. Let's run this one. And I've just, I don't know if this is gonna. I think this is gonna be a bit easy, but let's see. Here we go. These are flat Earth quotes and sayings. So let me put this up. Where are we? Where's the PowerPoint button? PowerPoint button. Where are you? PowerPoint. There we go. Still finishing. We're still talking in Finnish. So let's finish the quote. Okay. You will notice that they're all by unknown genius because I told you who made the quote that would give it away before we even got
Unknown
started.
geniuses.
The genius is unknown. Might be a better way of putting it. Okay. Let's start with this one.
This is an egg. That's an easy one. Come on.
Well, that's gonna say you're gonna find them all
Yeah.
fairly easy. Not. I mean, what else do you do? Got it? This one's used a lot. Do I have to give it up more letters? Anyone out in the peanuts got this one? Yeah, you can see I put more spaces between the words, make it easier. Okay. That should give it away. Yay, Clive's got it. Got it?
Yeah, yeah.
Yeah, cannot have gas pressure without a container. Should be cannot. Look, I'm doing it my way, which you're probably right. Which... Okay, next finish quote. Let's see. Another unknown genius.
Interesting.
That's
yeah.
Interesting. Yes. Okay. Next one. Yeah. Maybe that. Any idea? Might be a little bit trickier, this one. I'll give you another letter. Or some more letters. That's the last word. If you got that, I think you get the rest.
Oh, I know it's Antarctica, but
Yeah. Anyone?
You'll be arrested if you try and go to Antarctica.
Yep, that's the one. Okay. Yes, Carl, you got it. I need to speed it up. Speed up your feed, because you're a little bit behind. Okay.
The Earth spins at 1,000 miles per hour.
That's the one. Okay. And Blue should get this one.
You can do that with an angle.
Yep.
You might notice it's just unknown. Yeah, give me another letter. Or small letters.
I thought that one might give it away. Turing test is sort of on it, but not quite there. It is. Clive's got it.
Huh?
Spectroscopy means a container.
Never heard that one.
Have we? What have we heard then? Isn't that what Dave said? No, we got that
That
one
was
wrong.
Dave Weiss.
Yeah.
Well, it's
I don't
actually
listen to Dave
spectroscopy
Weiss.
needs to be in a container.
Yeah. Well,
Oh.
might have been, but
Oh, I don't listen to that idiot.
This is the liar.
he is. He's a con man. So might be a bit tricky. Derp means derp. That's right. I'll give you another. Still not enough. Okay. Another letter might give it away. Hopefully I spelled everything right. That would make it much harder. Trying to work out my spell. Okay. There you go. No one got that one. Any ideas? Or have you all gone to sleep? What word has a Z starting with it? Or Z if you're blue.
You can bring a boat back from over the horizon by zooming in.
Yeah, that's the one. Yeah. Okay. That's it, Clive. You got it? It's only 2 words. Yay! Turing test got it. Yeah. Okay.
It's just perspective.
That's it. That's correct. Okay. Unknown. Alan should get this one.
Level is horizontal.
Yes. Bev. Yes, it was Bev.
The sun is small and local.
Yep, that's it. We got many more to go. We've got.
A randomizer is pretty nasty, actually. Let's see, next one. No one? Ah, yep, there we go. Turing test got it. Flat and stationary plane. Okay.
No, we don't.
Okay. I might give it away. There you go.
Sunsets only work on a flat Earth.
Yep. Sextants only work on a flat Earth.
Sextants, yeah.
No. There's a few things that would have fitted. That's okay. Ready? Yep. I don't think that won't help much.
Navigation only flat maps.
Yeah.
Navigators only use flat maps. Yes. The author may give it away. You may have owned how many.
Earth is not flat. There are hills and valleys.
Yes, that's right. And... Let's see what my randomizer does. No, no one yet. Not even the peanuts. Okay. I'm sure if I told you who it was, you'd get it straight away. Her name starts with M. What?
No such thing as
What's the last one? Last word.
Oh, shadows, but
yeah. What was Marissa's favourite? One of Marissa's sayings. Yeah, that's the one. Carl Ellerwood's got it. What's that thing? Is southwards facing shadows?
Yeah. Never heard that one.
No, that was one of her claims. Apart from the North Pole being in the north of Africa, but that was known genius. I think this is the last one. The capitals are correct. No? Alert. Last one, alert. See if you can get there. Carl's got the last one. Last bit of it. What's the rest of it? Anyone finishes off? Don't know the first bit though. How can you not know the first bit, Carl? There we go. Turing test, got it. There we go. Oh, that's it. Pick another subject next time. Oh, see, I've got it even down to a push a button. You can't see that. I don't think you can see that. No. Okay. Oh, I'm glad you enjoyed that. It's good. I'll do another one, but I might pick another subject. You do run out of flat earth quotes very quick. Oh, okay. Well, I'm just going to put on Everett for a sec. Yeah, I think we've done this, Everett. Let me know. We've done this, Everett. Oops, that's Everett.
Everyone.
Music. Now, have we done this? Hang on. Again. Have we done this one? Yeah, this one. That's the guy that went home to his wife and told him that the earth was flat because someone had told him at a conference that the earth was flat. Christian conference. Ah, yes, we did this guy because he reckoned the inside of mountains was the inside of giants. Must be up to this one. We haven't done this one. Here we go.
You asked for evidence? Well, you're gonna get it. This is actual satellite footage from NASA saying that this is the dark side of the moon, 1 million miles away from Earth.
Space pants! Space pants! I am wearing space pants!
What is this? Oh, I'm sorry. Is what's going on up there more interesting than what's going on right here? Kind of.
Space pants!
Now, I want you to imagine yourself standing on the surface of that moon, looking at that Earth. We're 1 million miles away, remember?
It's just where we're at.
Okay, this is just our noon normal.
What is noon normal?
You know, it's like when the day's going great, and then around noontime, it just, I don't know.
Now here's an Apollo mission photo from the moon. As I have said before in previous videos, if that were the case, this Earth would be taking up all of the viewable sky.
Oh, what an idiot.
Yeah. There. You'll be okay.
Al, you need to get some rest. Or help of some kind.
Apparently, the 1,000-mile-hour spin of the Earth is supposed to cause it to look like this, yet we are given perfect spheres.
Getting the spirit. I guess I underestimated you madly. Wait. Here.
Let's say the 1,000-mile-per-hour spin did fight our gravity. Well, don't you think that being that the water is so sensitive to gravity that the moon can cause tides, don't you think that the spin of that Earth would fight gravity so much that all the water would be around the equator area? All the water would just make a belt around this globe.
I've been living alone a long time now. Well, I think that's the tops.
They make fun of you. They think you are so dense that you won't see all these contradictions and start putting things together to find out that they're lying.
Open up your eyes, man.
They're trying to control global warming. Get it? Global.
And if that spin was strong enough to create an Earth that is shaped like this, what more would it do to the water on that Earth?
Nothing for you.
So what was the Earth rotating around before the sun was created?
Nothing for you. Come back 1 year.
As the sun sets, it turns into an itty-bitty, tiny little itty-bitty baby.
The army destroyed all his brain cells with their deadly placebo drug. No wonder he's an ignoramus.
What did you say?
Ignoramus. It means stupid, you moron.
Well, could it be that it's moving further away from us rather than going down over the other side of a ball?
That makes a lot of sense. A lot of nonsense.
Does this look like it's right on the horizon? Well, as a matter of fact, it's tiny. And it's not even close to the horizon right this moment.
Eight-year-olds, dude.
The density of air causes the magnification effect that makes it look as if the sun's huge at the horizon when, in fact, it's itty-bitty tiny.
You know, I'd be happy to prescribe something for that.
I kind of want to go back to Enoch when the angel came and told him about the cosmos and how the sun worked.
And you're an idiot.
The angel mentioned that the sun went through 6 portals, and sometimes when you see that sun shrink to a little bitty sun, it's traveling into a portal at that time and coming out at another place.
How many science classes do you have to fail before that even comes into the realm of possibility for your half-incestual ass?
Well, I think we might be getting close to calling it a night. We have lost Blue there somewhere along. Oh no, we lost Alan somewhere along the line. Ah, there we go. Missed that one.
Mm-hmm. Yeah, I'm here.
You're here.
Alan dropped.
Alan dropped it. Yeah, no. I was looking at the little image. I read the big image. Yes. I think I might give that a call there tonight for tonight, unless if anyone else has got anything they wanted to bring up. I do have Matt. So if people go to Matt's channel, you'll find a nice little video telling you about what launches etc. are coming up. So I recommend you wander over there. Have a look at
Oh. Ouch.
Ouch. Ouch.
Stop that.
That sound?
Yeah.
You might have to talk to
Blowing my headphones up here.
Yeah. Well, that's his intro for this little piece of stuff. And then he has the mystic music in the background. So yes, if you wanted to find out what's coming up, I recommend you wander over to his channel and have a little look. Oh well, we might while that plays in the background, I might say goodnight to the Peanuts. You guys want to say goodnight to Peanuts?
Good night, Peanuts.
Good night, Peanuts.
I'll catch you again later. Probably, definitely on the weekend, maybe on Wednesday. We'll see how we go. Okay, guys. See you later.
Remember, asymptotic is not azimuthal.
It is not. It is not. No.